Hello students, today we are going to discuss about declaration of variables and operators and expressions, that is arithmetic and relational operators. After completion of this lecture, you will be able to apply the suitable operators required for the program. Students, in C there are different types of variables. Among the three, these are the three basic types of data types we have: integer, float and character. Integer number indicates the only numbers which are not containing any decimal numbers. It can be positive number or negative number. And float numbers indicates some decimal numbers. So they can be also positive or negative decimal numbers. And characters indicate only the alphabets within the range A to Z. And C is a case sensitive language where small a is different for C and capital A is also different for C. We indicate a single letter in terms of single code, which is called as a character. If you want to use multiple letters, we use double quotes, which is called as a string here. And this is a character. And double quotes is to be used compulsory to indicate that it is a string. These are the examples for the number, students. We are declaring some integer number 15. You can also modify this using this one. Number equal to 10, you can modify it in the next line. So this is a syntax for declaring any variable. What is the data type we have to declare? Followed by the variable name and value. So in place of data type, we can write int, float or character. If it is integer, the number is to be simple number without any decimal. If it is a float, you can also declare it as a float number with the variable 1 equal to 5.4. This is for float. And if you want to declare some character, okay, you can write character variable 2 equal to some a followed by semicolon. This is semicolon indicates the end of a line. So this is, so variable 2 will store its value as a, and float will store the value as decimal number, and integer will store the number as a simple number without any decimal. And these are the format specified, students. So this is sample program which shows the declaration of all the three variables: integer, float and letter. And this is the starting part of any program. C program, int main followed by open brace, and this is return 0 followed by close brace. Now this is our header file. So this is a supporting file which will help us to help the processor to understand the total program. So this is a compulsory condition. Then we have the starting point of the program and we have the ending point of the program. So these are by default we have to write. This is like your start symbol in the flowchart and this is like your stop symbol in the flowchart. And here we after this we start with our declarations followed by semicolon at the end. So this is integer declaration, float and character, and some values are assigned to this. Then printf variables are there. Here we have print. Here we have print statement. If you want to print any value of a particular variable, we have to use these format specifiers. These are called as format specifiers. That is percentile D, percentile F, percentile C. See, num variable is there. This is carrying what? It is carrying an integer number. So that is why we have to use percentile D here. Float, it is containing some float number. So it is percentile F and this is character. So we use percentile C. And that should be kept in double braces. Followed by this percentile D is related to which variable? Num. So that num we are writing over here. This percentile F is related to float number. So we are writing float number. Okay, percentile C is related to this variable letter. So we are writing here as letter. Right. Then we are using slash n also. We are using slash n to indicate that when our output is displayed for each printf, okay, it should be printed in separate line. Okay, not all the things in one single line. So that's why we are using this. So first one, printf percentile d num. This will print 5. After this, due to this slash n, cursor will go to the next line and it will wait for the output of the next statement. Then here, the next statement float num printf float num, it will print 5.99. And after printing this, it will go to slash n. Slash n is there. Slash n indicates next line or new line. Okay, slash n is what? It is a new. So it will wait in the next line. In the next line, we are asking the processor to print the letter, the value which is assigned to letter. The value is D. Okay. Then again slash n is there. It will wait for the next printf statement. Here there are no printf statements, so it will be kept blank. In this way, outputs will be assigned one after the other. If you use slash n, it will be more clear to you. Okay. And this is simple statement. If you don't have any values, if you don't want to print any values, if you just want to print any statement, you can use this one, hello world. Okay, so this is the default for any program students. Header file followed by the starting of the program, return 0, which is the like stop symbol of the flowchart. Simply print some statement within double quotes. Okay, so here also you have to use double quotes where you want to print the values. If you and for writing the variable name, you did not give the variable name in the double quotes. You have to use comma followed by the variables, the list of variables. And we are writing int main and return 0. What is the purpose of this? See, whenever a program is executed successfully, this total program will return 0 value to the processor to indicate that program is executed without any errors. If any errors are there, this program will return 1 or non-zero, some number other than 0. It will be written to the processor to indicate that some errors are there. So we instruct the processor to return 0 if it is executed properly. And this 0 is what? It is integer. So that is why we have to write int here. So this return 0 is what? To this program, to this total program main. Main is the indication of the total program. So what is the data type? Main will be collecting this 0. So to collect the 0, to collect this one, it should be of same data type. That here in the previous program, if num is collecting 5, this variable is storing 5, this should be of same data type of 5. So that is why we are writing num as int. Similarly here, return 0, this 0 will be taken by main. So if main want to take this 0, it should be declared with the data type of this particular number. So that is why it is declared as int. Okay, so this is just like int main equal to 0. So this syntax we have to follow, students. The next one we have constant int. Constant in my num equal to 5. Whenever you are declaring any variable as constant, the number can't be changed. Without constant, if you simply write int my num, then the value of this variable can be changed. Next line, if you try to assign another value to the same variable, it will show error. So basically, int, character, float, these are basic data types or primitive data types. Okay, from this, additional data types are derived, which are double array, enum, etc. So these are called as derived data types. One more example, to add the two float numbers, you can write any statement. Along with the statement, if you want to print some value, you have to give the variable name of outside the double quotes, and after comma, you have to give the variable name. And what is the data type of this? That data type has to be given here in the within the double quotes, %f slash n. Slash n is optional. %f if you give the result of this total. So total is actually storing the value of num1 plus num2. The result which is stored in total, that will be displayed. And in C programming language, float numbers by default, after decimal, they take 6 digits. Okay, if you are simply giving 6.1, the remaining 5, okay, after 1 nothing is there, then by default the processor will fill up it with zeros. Similarly here, after decimal, we should have 6 digits. If you are giving only 3 digits, remaining 3 places will be occupied by zeros. So constants are the fixed value, students. They remain unchanged. So these are the 4 basic data types we have: integers, float, characters, character or string constants, which means same. And this is how we represent any number. Okay. In the declaration part, we can use this L or capital L for long integer. For unsigned integer, we can use U or capital U. For unsigned long int, you can use UL or capital UL. So integer will take 2 bytes. Long int, whether signed or unsigned, they will take 4 bytes of memory to store the particular data. Unsigned means you are simply assigning some positive number. Signed means some negative number can be assigned. You are assigning a sign before that. And just like the normal numbers we have, uh, like integer numbers, okay, we are also having some numbers like octal numbers and hexadecimal numbers. So if we consider our number format 0 to 9, okay, so the base of these decimal numbers will be 10. Okay, 0 to 9, total 10 numbers are there. Similarly, octal numbers, the range is from 0 to 7 and base is 8. Similarly, hexadecimal, it has numbers from 0 to 15. Among this, we have 0 to 9 numbers. After this, 10 to 15, we have capital letters and we have 15. So these are the total numbers which we have in hexadecimal and the base is 16. So we have discussed about constant variables where the value of a variable can't be changed, and volatile is the value of a variable can be changed. You see here, integer variable is there. It has been declared as constant. In the next line, we are writing it as x plus 1. X plus plus or x plus 1 is same. So x equal to x plus 1 if we have to write in this manner or x plus plus. That means you are incrementing the value of x, which is not accepted. This will show an error. You can't modify a constant variable. Next one, we have type conversion, students. Type conversion is a process where you are trying to convert a data type of a variable to either higher data type value or lower data type value. Now, what does that mean? I'm writing float b equal to 5.6. If I want to add these two, processor will not allow this. I can't add a variables which are of two different data types. Either both should be int or both should be float. So now this can be done in two ways. Conversion of the data types to either int or float. One is explicit typecasting, okay, done by user or programmer. Another is automatic typecasting or implicit typecasting, which will be done by the processor. Okay, we need not bother about this. So implicit type conversion, lower data type values will be converted to higher data types. In explicit type conversion, higher data types will be converted to lower data types. Now, what do we mean by lower and higher data types? It depends upon the memory. Integer here it takes 2 bytes. Float will take 4 bytes. Now, which is higher data type? Float is higher data type because it is taking more amount of memory. So if you want to convert smaller data type to higher data type, it is called as implicit type conversion, where if you give the statement like c equal to a plus b, a will be converted to float automatically by the processor. And if you want to convert the float b into int type, that is higher data type to lower data type, then programmer has to do it while writing the program. So it can be written in this manner: c equal to a plus int b. So before the variable, you have to mention the data type. This will convert b to int. So both will be of same data type, and then the result will be of integer type. So this is again similar example. And these are the bytes which will be taken by each type of variable. Character 1 byte and short int also 1 byte. Normal int will take 2 bytes, long int 4 bytes, float 4 bytes, and double 8 bytes. So the length of the memory will increase from bottom to top. So this is an example of explicit typecasting. These are the different arithmetic operators we have. And this plus plus indicates a plus 1. Minus minus indicates a minus 1. If you want to increment value of a variable, that is by just one value, incrementing by only one value or decrementing by one value, we can use these symbols, plus plus or minus minus. And these are the basic arithmetic operators. Now this will give you the quotient and this will give the remainder when you divide any number. And this is how we evaluate a arithmetic expression, students. We have minus, star, division, plus, and again division. We have the operators in this manner. So these are all the operators which we have in this particular expression. How this expression will be evaluated when such arithmetic operators are given. For this, some rules and regulations are provided. You see here, star, division, and modulus operation. They have higher preference when compared to plus minus. These are higher when compared to plus and minus. Higher in the sense, in the expression, first these will be executed, then only plus and minus will be executed. Now you see here, I have multiplication, division, and again division. Now these three should be executed first. Now the question is, among these three, which one is to be executed first again? For that, some precedence rules are given. Association is also given. Here direction is indicated from left to right. That means when you are evaluating the expression, left side of this expression is, it is starting with 3. Okay, it has to move along this direction to the right side. Okay, so this is left to right direction. So in reading the expression from left to right, whichever symbol is coming first in between this star, division and modulus, that particular expression will be evaluated first. So that is called as association, left to right association. Okay, so if you move here, so first we have to execute multiplication division operations. Okay, so among these three, star operation is coming first. So this will be executed first. 5 into 7, 35 is executed. Then this symbol will be executed first. Okay, this is coming first prior to the 6 by 2. So 35 divided by 8, we get this answer. Then 6 by 2 will be evaluated, we get 3. Now again minus and plus both have the same preference. But when we are moving from left to right, this is coming first. So first difference of this is calculated, then 3 is added and we get the sum in this manner. So this is how an expression is evaluated. Okay, so x percentile y will always give the result in terms of the remainder. And this particular symbol cannot be applied to float or double variables. So this is sample example, students. 3 variables are declared and c equal to a plus b is arithmetic operators are executed. I want to print the result of this. That means I need to print c. So how I will write? In double quotes, you can give any statement. So here I'm giving statement such that a plus b equal to is showing in the result on the screen. And I want to print the number. I don't want to print c. What is the value present in c that I want to get? So 9 plus 4 equal to 13. 13 I want to get. So write percentile d. 13. The result is integer number. So integer number we have to use format specifier percentile d. Slash n indicates next new line. Okay, comma. After comma, give the variable name where the result is stored. That is c. Okay, and what is the data type of c? That you should give over here. C is declared as what? It is declared as integer. So here we write percentile d. Okay. So same thing here for all the statements. And then remainder equal to 0. Whatever you give under double quotes, all that will be printed. When you want some values, use percentile d or percentile f followed by the variable after double quotes. And these are the relational operator, students. We have less than equal to, greater than equal to, double equal to, and not equal to. Now, what is the difference between equal to and double equal to? Now, this first statement indicates that the value of b is copied to a. Okay, a is taking a value from b. The meaning of a double equal to b is we are checking whether a and b are having same values or not. If it is true, it will return 1. If it is false, it will return 0. Similarly, you can also check whether they are not equal to, whether A and B are not equal to. If they are not equal, if it is true, okay, that means A is having 5, B is having 4, some different values are there, it will return true. That value, the result will be shown, or it will be represented using number 1. If it is false, it will be shown using 0. So that is how we use these operators. And this is sample program for relational operator students. Whatever you want to print as a statement, you can print here. And if you want to display multiple variables, the order in which you are giving the format specifiers, in the same order variables have to be given. First percentile D will be taken by first variable, second percentile D will be taken by second variable, third percentile D will be taken by third variable. So here we are writing an expression, we are not writing single variable. A equal to B, if it is true, it will return 1. So here actually 1 is present. So that is an integer number. Okay, so that value is shown. So this is how output is generated. So in the same manner, we apply all the relational operators. Okay, so coming to the summary of the topic, students, we have discussed about 3 basic data types, int, float, and char. And these are the different arithmetic operators and relational operators we have discussed. And we have also discussed about implicit and explicit typecasting. Implicit is where lower data type is converted to higher data type by the processor itself. Okay, we need not do any job here. And explicit is higher data type is converted to lower data type, which have to be done by the user or programmer. So let us see a small query. Now answer the students. This is the expression, how the expression will be evaluated. There are different data types. Now the result will be of what data type? If it is implicit type conversion. Just take a few seconds and answer. So answer is T. Among these, the longest memory which is occupied is double. So float will take 4 bytes, into 2 bytes, long 4 bytes, double 8 bytes. So the total expression, all the variables will be converted to double data type. Second one, when do we need to use the type conversions? So the value to be stored is beyond the maximum limit. The value is to be stored in the form that is not supported by the data type, or to reduce the memory in use relevant to the value. So which one is correct? All the options are correct. Okay, for all these particular situations, we go for the type conversions. After completion of the discussion on variables and operators, students, you will be able to apply the suitable operators required for the program. And these are some lecture level questions. Okay. And if you have answered the queries, uh, then it is okay. If you have got wrong answers for this, you can just revise the video again. Thank you.